Welcome to Probability and Statistics. In this lecture video, we're going to talk about how to find probability using a normal distribution. So in the last two lecture video, the first one back in 6.1, we talk about how to standardize our normal distribution. Okay, convert my random variable x into a z-score, and then in 6.2 we talk about how to find the area under the curve by having a z-score already. So now let's put the two sections together, and we're gonna actually start off with an actual application problem. So what we're gonna do is find our z-score first, then we're gonna draw our normal curve so we know which side of the area that we are going to be looking for, either to the right, to the left, the two tails, or what's in between. Then we're going to put it in the calculator for the normal CDF, alright, to find the area or the probability under the curve. Alright, so let's get started. I'm going to copy my formula from the 6.1. Alright, so the ARC Electronic Company had an income of $104 million last year. Suppose the mean income of the firm, so that's a key word right there, the mean income of the same industry for a year is $85 million with a standard deviation of 19 million. If income for this industry are distributed normally, what is the probability that a randomly selected firm will earn less than ARC did last year? Alright, so basically what we know is the mean is going to be located, the mean is $85 million for the industry. This particular company had an income of 104, so that will be to the right. Alright, and I got my standard deviation $9 million at the time. So the idea is, this is my random variable x. Now I need to convert it into a z-score. So I know my mean is always located at 0. So the z-score I'm trying to convert is the 104. Alright, so let's write down what we know. Okay, sometimes that will help a little bit. My random variable x is $104 million. Alright, with my mean, oh, I can't type this. Okay, write it. With my mean of the industry is 85. Alright, my standard deviation sigma is at 19. Alright, and what I'm looking for is less than, so that will be to the left. So we gotta figure all of this out before we begin looking for what is less than. So that's looking for everything to the left of 104. Alright, so let's convert into our z-score. So my z-score is going to be my 104 minus my mean divided by standard deviation. So I'm trying to see that 104 million in terms of standard deviation, how far away is to the mean. So 104 minus the 85 first before I divide it by 19. So this is exactly 1. That means the 104 is only one standard deviation to the right of the mean. But what I need to find is to the left. Okay, So area to the left of my z-score 1, there's no left bound, so we will type in negative 1e99 all the way up to 1. So that would be normal CDF negative 1e99 comma standard all the way up to 1 comma mean is 0, standard deviation is 1 at a is 19. Excuse me, standard deviation 1 at a time under the standard z-score. So how much area or what's the probability to the left? Second distribute number 2. Negative 1e99 comma 1 all the way up to 1 comma 0 comma 1. Alright, 4 decimal place. So all this area to the left of my standard deviation 1 is 0.8413. Okay, that's all that is to it. Alright, let's go look at another example and see where does it want me to find. So this is everything we've done before. We just put them together in an actual application. So let's say a soft drink machine, this is a very neat problem, outputs a mean of 26 ounces per cup. The machine output is normally distributed with a standard deviation of 2 ounces. So that means, you can give, plus or minus about 2 ounces because you don't want to overflow. That's you don't want when these machine, when these machine put out drinks, it's always never all the way to the top. It's a little bit of room before you will fill it up, because it got a give and take about so many ounces, so you won't overflow. What is the probability of overfilling a 29 ounce cup? Alright, so my mean is 26. The machine is supposed to output 26. My random variable is overfilling 29 ounce. So 29 is my random variable. My mean mu is going to be 26 ounce with a standard deviation 2 ounce at a time. Alright, so I know the mean 26 is in the middle. 29 should be a little bit to the right. Before I convert to a z-score, what am I looking for? To the right or to the left of my 29 ounce? To the right or to the left? When they say overfill means more. So the wording overfill here tell me I need to look at what is to the right. What's my probability of overfilling? That means I want more than 29 ounces. Alright, so let's convert our 29 ounce into a z-score. So mean is at 0. This is my z-axis. This is my x-axis normally. So let's see what we got. With this formula, there will be 29 minus 26 over standard deviation is 2. Your answer will be positive because the 29 I'm trying to convert into a z is to the right side of my mean, so it will be positive z-score. Anything to the left side of my z-score, left side of my mean should be negative z-score. So this is going to be 3 divided by 2, right? Subtract divided by 2, which is 1.5. So that tells me that the 29 has become 1.5 for internal, 1.5 place to the right of the mean in terms of a standard deviation. Alright, so since I'm looking for area to the right, my lower bound got to be the 1.5. Keep on going to the right to infinity, so my infinity got to be 1e99. Keep on going to the right. Alright, so that will be normal CDF starting at 1.5 as a left lower bound, comma, 1E99, comma, mean is 0 for standard deviation, mean is 0, standard deviation is 1 at a time. Alright, let's see what I get here. Second distribute, number 2, 1.5, comma, 1E99, comma, 0, comma, 1.0668. So I got about almost 7% chance I will overfill a 29 ounce. Okay, cup. Alright, that's all it is to it. Let's look at another one. The time spent waiting in line is approximately normally distributed. So I got normal curve. The mean of a waiting time is 6 minutes. And the variance, ooh, be careful. This word is variance. The variance of waiting time is 1. Find the probability that a person will wait for between 5 to 7 minutes. Okay, so this one is in between. So I know my mean is 6 minutes. You probably want me to find the probability between 5 to 7 minutes. Alright, so I'm just kind of sketching my graph a little bit. So I'm looking for what's in here. Alright, let's see what my z-score will turn out to be. Let's see, what do I know? My x, my random variable x is going to be 5 and 7. My mean, mu, is equal to 6. But this one is called variance. So that will be sigma squared is 1. So to find the standard deviation, we take a square root of my 1, which will still be 1. So this time I'm going to convert the 5 and the 7, okay, into the z-score. So let's do 5 first. Okay, let's do 5 first. I'm going to put them side by side, okay? Let's do 5 first, over here on the left. So my z equal to 5 minus 6 divided by 1, which will be negative 1. So the z-score here is negative 1. The other side, 7 minus 6 divided by 1, that will be positive 1. So 7 minute is standard deviation 1. I need to look for what's in between from negative 1 to 1. So that would be normal CDF from negative 1 to 1, comma 0, comma 1. Now, if you remember the empirical rule, that will be 68%. One standard deviation from the mean is 68% of your data. But this is actually a little bit more accurate. We need to run 4 decimal place. Comma 0, comma 1. It's actually 0.6827. Okay, that's a more accurate answer. 0.6827. So that's why normally, empirical rule rounded to 2 decimal places, something like that. Alright, so that's how we do it for the in-between. Alright. Trucks in a delivery fleet travel a mean of 80 miles per day with a standard deviation of 30 miles per day. So some drivers will drive 30 miles less, some driver will drive up to 30 miles more. The mileage per day is distributed normally. Find the probability that truck will drive at least 52 miles. Alright, so this is at least. So the mean is 80 miles. At least 52. The 52 is actually to the left of the mean 80 miles. What does the word at least means? At least 52 means 52 and more. So that means I'm looking for everything to the right. Okay, looking for everything to the right. So let's convert our 52 miles into a z-score first. Then we can find the probability to the right of it. So the random variable I'm looking for is 52 that I need to convert. I use the equal sign here. I meant to write greater than, because that's what this problem wants, greater than. But it's okay, no big deal. Mean is at 80. Standard deviation is 30 miles. Alright. Now I highly recommend you follow the way I'm doing this. Convert it into a z-score first. I have seen a lot of students who will type in the actual numbers, okay, in a normal CDF without converting to a z-score. That method will work for right now, but eventually when we head into other chapters, the standard deviation part will actually be a little bit different. So your answer will be thrown off quite a bit. So if we can practice converting to z-score, okay, use a formula converting to z-score and put in a calculator, the answer will be correct. Okay, there are other ways to do this, but I find it it's easier to just do it the uniform way, do the same methods. Okay, the only thing different between this chapter and the other chapter is the z-score part. Okay, certain part of this formula will change a little bit based on the type of distribution that we'll be talking about. So again, it's easier to just start practicing to use this technique. Alright, minus the mean divided by standard deviation. So 52 is how many standard deviation away from the mean. Okay, that's what the z-score is saying. This should be negative, right? 52 minus 8 should be negative. Subtract first, okay? Then we divide it by 30. Z-score always 2 decimal place, so there'll be negative 0.93. So this 52 is negative 0.93. I'm looking for the area to the right, so there's no upper bound, so that will be infinity, which we type in 1E99. Should be negative 0.93 to the right, comma 0, comma 1. Let's see what my probability is. At least 52 miles a day. Sorry about that. That's 3, not 2. Negative 0.93, comma 1E99, comma 0, comma 1. 0.8238. So there's 82% chance, okay, that driver will drive at least 52 miles. All right. So this problem will conclude this lecture video. So this lecture video is really talking about how we read the application problem, okay, convert my random variable into a z-score, and then so we can find the probability either to the right, to the left, or in between. Or it can be the two tails too. We just did not do a problem like that. Now, the next lecture video, 6.4, we were actually talking about backwards. Everything we're doing in this video backwards. So that means rather than find the area under the curve, rather than find the probability, okay, we actually need to go back and finding somebody else inside this formula. So I will give you the area first, and I will ask you for, I will actually ask you for either the random variable x, or I will ask you for the standard deviation, or I can ask you for the mean. Okay, there are 1, 2, 3, 4 things in this formula. If I give you 3, if we can know 3 of them, we can find the missing one. Okay, that's what we're gonna do in the next lecture video. All right, thank you for watching.